So today I want to welcome Alberto Ortiz, Michael Patton, and Matthew Ferry, who will be our presenters. They're all part of our Controlled Air team. They'll be discussing the future-ready building solutions, meeting energy and comfort goals in a changing world.
Thanks, Kendra. So my name's Matthew Ferry, and I'm an energy solutions developer for Controlled Air. First of all, I'd like to introduce you to Controlled Air, and then we're going to talk about electrification and finally the solutions. So Controlled Air was founded 4 decades ago as an HVAC business, and its core business grew from 4 people to over 100 today. The company was founded by Vince Kiokio, who is still the current president today. And around 2010, the company started to do projects with Yanmar and became a master distributor. And the relationship led to Yanmar acquiring Controlled Air in 2022. And the object being to create an engineering excellence and service solutions company to be part of their US operations. So the plan is for Controlled Air to continue as a leader in the industry in HVAC solutions and energy efficiency, but also to grow its business into energy solutions market. It's a very, very licensed company. I'm not going to go through all the listings here, but suffice to say we're well certified. So let's talk about the team. So we have more than 100 staff, and a lot of the employees have been there 20 years or longer, which not only says it's a great place to work, but it becomes more of a community. And that's evident in the commitment to excellence and teamwork. Controlled Air's team are very experienced at solving any kind of building or facility challenge, from a simple boiler replacement, a thermostat change, right the way through to turnkey systems. We also have full engineering capabilities in-house, which allows us to generate our own plans and designs. Our team is comprised of skilled professionals. Each is specifically trained and certified in different areas of the business, technology, engineering, HVAC, energy solutions, as well as project development and execution. One of the important things that we have to remember is not just to do the projects, but it's also the ability to provide operations and maintenance services for everything we design, build, or install. We aim to give our customers complete peace of mind. So a little talk about the process. We're a very adaptive group, but we do have a set of cornerstones that we work from. We get to know our customers, we learn about their businesses, and more importantly, we learn what keeps them awake at night in terms of energy, cost, or reliability. Then we undergo a process which I'll briefly outline below. We have initial discussions with the customer just to find out about the company, the energy use, how it works. We exchange utility data so that we can review that to build an energy model, and usually conduct a site visit to really get down in the weeds and see what's under the hood in the HVAC rooms and the electrical rooms. We develop an energy model there, which gives us points to look at for improvement and technologies that may work to make those changes. That brings us to a high-level cost estimate and discussions with the customers on how we can work together to make this happen. Is it something they want to purchase, or is it something they'd like to look at with an energy services agreement? So you can really break any project down into 4 facets. for an energy solution. There's the technical facet, which involves selection of technology, modeling, design, permitting, installation, to name a few things. That's one whole section on its own. The environmental concerns. What are the site constraints? What is the impact of doing what you're trying to achieve going to be? Is it going to be legal? From a legal perspective, there will be contract negotiations, utility company agreements, purchase agreements, and a lot of legal work to get us to the point. Financial, this all sounds great, but how can we afford it? Well, we could structure it in an energy services agreement, which makes these projects affordable for customers and have the benefits of OPEX versus CAPEX. So it allows you to make almost like a monthly utility bill payment versus a large capital outlay. Often, we're responding to situations where deferred maintenance has caused an unbudgeted problem. So you have to be master of all of these facets in order to make projects happen. So I'm not going to list all of the technologies here in our specialties, but suffice to say, after 4+ decades in business, we've had the opportunity to work with our customers to deliver everything from boilers to HVAC, scientific clean room, geothermal systems, microgrid and nanogrid, right the way through the whole gamut of services for a really wide array of customers. Excuse me. Most of our customers come from repeat business. Some of them we've been working with for decades on different properties and growing with them as their businesses grew. Our customers include educational, municipal, communications industry, commercial real estate development and redevelopment, scientific, pharmaceutical, a wide array of customers over a wide array of industries. So now we're going to talk a little about electrification, what this means and what the effect is going to have on us. So the big question, what is electrification? People have heard about it. People seem to have different definitions. Simply put, it's slow elimination of fossil fuels to make energy, which means that buildings and plants will switch over to electric powered heating or cooling technology versus fossil fuels. It sounds simple and it will certainly change the environment, but it's not an easy thing to execute. So what are the challenges? Well, it's going to mean a huge increase in electric use. It's going to mean a large increase in energy costs because utility companies will have to invest in transmission upgrades, and those investments will have to be paid by rate-based hikes. EV charging. Every year, the number of electric vehicles registers currently increases by about 3%. And to compound all of the things going on, utility companies, like everybody else, are businesses, and they have to slowly retire financially non-performing generation capacity. If it's more expensive to make it smog compliant, why continue to operate? So this new grid's going to require a different paradigm than we have today, and much more use of renewables and storage. So what does the picture look like today? Well, New England has the fourth most expensive utility costs in the USA. On the plus side, it ranks as the fourth most reliable grid in the United States. But because of the increase in inclement weather events and the frequency and intensity we always seem to be plagued by storm damage or outages. And one thing is for sure, energy costs are increasing. So what is it going to look like tomorrow? I think we're going to see much more of a picture where on-site systems provide customers with their energy, electricity, heating, cooling, and backup power, or the ability to disconnect from the grid if the grid is down. Customers will have little or no grid reliance if they have these systems. And under an energy services agreement, this would be financed much like a monthly energy utility bill. Systems are designed for long service life, they're cost effective, and they can be low or zero emissions depending on what the customer needs are. Real estate customers are moving towards self-generated power and building wide energy solutions. It protects their businesses and saves money. And the government and state programs are providing more and more funding, encouraging customers to deploy these projects. So the solutions, what is even an energy solutions? It can be as simple as a piece of equipment that makes components in an existing system talk to each other with greater efficiency, or it can encompass one or more energy technologies to actually go as far as making the energy to heat and power the building on site. It could be natural gas powered, but with far lower emissions than the electricity from the grid. Utility companies still have a robust natural gas market, and that's not going away anytime soon. In fact, we can create systems that power, cool, and heat the building with more cost efficiency and with greater reliability. It means you have predictable energy costs over 10 to 15 years. And that means the building has higher resale value. Owners and tenants also benefit from this, and it's much greener too. To do this, we develop relationships with vendors that provide best-in-class technologies. We've focused so far on solar, battery energy storage systems, combined heat and power, hybrid HVAC solutions, and controls to monitor and maintain and make all these technologies work together. So the technologies that we use, this is not going to be a deep dive, rather just an overview. So CHP, or combined heat and power, it's a system that makes two forms of energy from one fuel source, much like the car engine in your car driving a transmission. We have a system that instead of driving a transmission drives a generator. Instead of the car radiator dumping the heat, we capture it and recycle to either heat or cool a building. So BESS, or battery energy storage systems. Price on battery system storage has dropped 300% in the last 10 years, making it a very affordable and viable, almost like a router to combine the other technologies that we put together. It not only allows us to store the energy that we need when we need it and use it when we use it, but it also provides an excellent buffer to cover grid anomalies or high discharge, such as elevators. Solar, in our applications, we're usually not simply grid connected, rather used to charge batteries and load manage, and obviously microgrid and control systems to make all of these technologies talk together. We are now working with solutions to provide single spot and stackable parking systems, even working on our first project for hydrogen generation for transportation. Our sweet spot is to develop turnkey systems for customers using technology choices for that specific building application. We have a very agnostic approach to the right technology. We can often do this with 30% savings in energy as well as great increases in reliability. We bring the cost down by leveraging federal or state grants and incentives to minimize the cost. In fact, as a concept, we've done this for customers where we take the entire budget for an HVAC system off the balance sheet of the project by providing an energy service agreement. Again, it becomes operating capital versus capital expenditure. This is great for customers who have projects that have overrun budgets or at the early design stage and want to outsource the heating and cooling system. We work with new construction and rehab. It's best if we can work with you as early as possible in the design stage so that we don't waste money by designing once and then revising again. So thank you for listening to me with the information. I know it was a lot to digest. I'd like to hand over now to my colleague Michael Patton, who's going to talk about HVAC solutions. You're on mute, Michael. Michael, you're on mute.
There we go. My unmute button wasn't working properly. Thank you, Matthew. My name is Michael Patton. I'm a design build sales engineer with Controlled Air. And I'm going to discuss today the different HVAC solutions that are available and what's coming down the pike as well. So when we're going to look at the legacy technologies. These are systems that you probably have in your own building right now. These are things that we continue to service, we continue to sell, and we continue to replace. The new emerging technologies can be utilized as we'll discuss a little bit later. But these are things that we are currently working with and servicing and installing. So when we're talking about hot water systems, there's lower efficiency fossil fuel, oil, and natural gas boilers. And then if you have the right conditions, you can put in a high efficiency natural gas condensing boiler getting up to 97% combustion efficiency. There's electric chillers and cooling tower pairs. Those will be around for quite a while, and they're not going anywhere anytime soon. There's also the opportunity to look at air-cooled chillers for expansions or replacing water-cooled systems. There's condenser side water economizers, which provide free cooling for shoulder seasons, utilizing the cooling tower to cool the water down and let a heat exchanger put that into the chilled water loop. Water source heat pumps have been around for decades. We don't see many new designs with them. They've been replanted or supplanted by a different technology I'll discuss in a minute, but they still need to be replaced. You still need to maintain the boilers and the cooling towers that go with those systems. Fossil fuel electric domestic hot water heating is still going to be around, whether it's oil, natural gas, or electric. And with tighter building envelopes, fresh air for ventilation is becoming more and more important, and in some cases, compliance with code requires upgrading a system. The variable frequency drives have been around for decades as well, for motor energy savings, where you reduce the speed of the motor to save energy. And for larger hospitals and campuses where there's steam systems, those large steam systems will be around for a while. Those boilers will be replaced as they age out, so that's not a technology that's going anywhere soon. But one of the things we find frequently when doing building surveys is that the electrical service or utility constraints are making us look at how to be more forward thinking as far as reducing the electric load at the building site itself. And certainly Matthew covered a lot of that. So for technologies that exist now and are emerging and coming in the future, there's a new thing called a heat pump and hybrid boilers, and I put that in quote because we're going to discuss that a little bit more detail. There's heat recovery chillers that can boost the hot water temperatures to take care of other building loads. There's liquid to liquid heat pumps that will both heat and cool. Air to liquid heat pumps, which will do the same thing, heating and cooling. A new technology that's basically replaced water source heat pumps is variable refrigerant flow with simultaneous zone heating and cooling. So one zone could be cooling, one could be heating, and very, very efficient and very energy efficient as well. Potable water heaters with heat pumps have become quite a thing in the last several years. That's basically putting a compressor on top of your hot water tank and using the heat of compression to heat your hot water rather than electric or fossil fuel. They work really well, and again, they're increasing in size practically daily into commercial sectors. There's demand control ventilation, which regulates the amount of CO2 in a space, so you're not or you don't have to heat or cool outside air to maintain comfort for the occupants. There's DC motors and ECM motors, that's electrically commutated motors that have built-in speed control to run your pumps and fans. These are becoming more and more prevalent and increasing in horsepower availability as well. For air handling units and air moving equipment, there's fan wall multi-fan motor units using primarily ECM motors for supply air fan systems. What happens in a case like that, you have an array of 3 or 4 supply fans. If one goes down, the other 3 will increase the speed to maintain the proper pressure and air delivery in the system. Matthew touched a little bit on natural gas driven heat pumps. That's a great option if you have electrical constraints with utility or the building service and you don't want to upgrade. Then we have DOAS, dedicated outdoor air systems for ventilation. And these can use either enthalpy wheels for total energy recovery from the exhaust air or sensible plate heat exchangers for that as well. And as Matthew mentioned, there's alternative energy sources that can be site generated, wind, solar, battery, and CHP. And of course, wireless controllers and end devices are emerging and are going to be essential, especially for complicated or difficult building renovations. So let's talk a little bit more about heat pumps for hot water building heating systems. And I've broken this down into 2 different phases. One is if you've got a new construction or a total renovation, and there's a couple different things you want to look out for these. So these hybrid heat pumps will output lower water temperatures. So we're not going to do the high temperatures that we're used to. It's going to be much lower water temperature. So depending upon the system selection, these will require more area for equipment siting. The equipment is very highly efficient and we can use strategies to lower the demand charges such as thermal storage. So you're not at peak loads, you're not getting that hit on your electric bill. For renovation, basically a complete mechanic room upgrade to the piping and pumps controls is required. The existing equipment, if you're replacing a fossil fuel hot water boiler with one of these new electric heat pumps, it's going to take up more space. And just keep in mind that that's a significant upgrade. But then again, you're as part of an energy services agreement, you can lock in a price for that electric use. And you'll need to replace your hot water coils, air handling units, terminal units, etc., because they're not sized properly. And with the lower temps, new equipment will be required for all these aspects. When we get on site, one of the things we are trained to do is to look at all the energy sources and needs of a building so that we can understand what the footprint looks like and what technologies we can bring in to supplant what a renovation or a replacement. One of those is heat recovery liquid screw chillers. They've been around for a long time. They uh, they need a winter heat source of about 80 to 100 degrees so that you can amplify that to about 160 to deliver water to the heating system. And these require sophisticated control schemes and fully automation because manual operation is not going to make this work well and efficiently. So let's take a look at a couple design concepts that this came from an ASHRAE journal article a couple years ago. So in the left-hand panel, we've got a building chilled water and hot water heating system coupled with a domestic hot water system in the lower portion. So you can see the pink boxes are heat recovery chillers, and the blue boxes are standard electric drive chillers. Not drawn in here is the cooling tower loop, which would still be required for this. But you can see that the heat recovery chillers, while producing chilled water for the loop, are also delivering hot water for the hot water heating system. And below that, you see heat pump water heaters flowing into storage tanks for surge control with surge uses. And the heat pump water heaters with the storage tanks provide a good domestic hot water, potable hot water as well. In the right-hand panel, this shows how this kind of a system can be integrated into a combined system, which will increase the overall efficiency of the system. So we still have the same heat recovery chillers and electric chillers, but now we've integrated the hot water heating loop to the domestic hot water heaters by replacing the heat pump hot water heaters and storage tanks with dual source fired fueled tanks where the hot water will exchange into the domestic hot water and also use electric backup if there's not enough energy being developed by the heat recovery chillers. So what this does, it makes the system much more efficient. And out of the study came a COP comparison. We call that the coefficient of performance. The higher the coefficient of performance number, the more efficient the system is. So in this case, we were delivering 115-degree hot water supply for heating and 46-degree chill water supply, and basically a domestic hot water at about 110, 115 as well. So in the base design, the COP ranged from 2.8 to 4.4, depending upon the operating mode and the outdoor conditions. In the hybrid model, the right-hand panel, the COP ranged from 2, but increased up to 5.8, much more efficient than the base design under simultaneous heating and cooling. The reason the low end drops on the hybrid model from 2.8 down to 2 is that we're using electric resistance heat in those dual source storage tanks, which makes it a little bit less efficient than the heat pump hot water heaters. So this is just an example of the kind of design that we can provide, and looking again at the total usage of the building and what the occupants' needs are for, and looking at it with energy efficiency. So that's it for me. I'm going to turn it over now to Alberto Ortiz, who's going to discuss controls.
Right. Thank you, Michael. My name is Alberto. I'm one of the design build sales engineers, and I'm going to be talking about energy efficiency and controls. And the reason why we have controls is really to optimize the performance, the life expectancy of the units, as well as energy savings. Well, with our system, we have seamless integration with different type of buildings, from schools to labs to industrial facilities, even office spaces. We are able to integrate our system for optimal performance. This system can deliver monitoring and adaptation of the system for the HVAC and contributes to the energy efficiency overall. Control systems tend to be complex and here at Control Air, we are aiming it to make it user-friendly for everybody. At the bottom, you can see some of our newest controllers. We are the ECIOs. They have the capability to use Wi-Fi integration, so they can go through BACnet, MST, Modbus, and we can combine them together throughout the facility to overall give us one point of command. Overall, we can have Wi-Fi integration, which means we have to limit the installation towards the occupants. So we have less disturbance by using the Wi-Fi integration. And we're able to escalate it into a form that we can take the overall view of the building into one point. It can either be a computer, or we can even integrate to our iPad or iPhones in order to see the real-time data from the HVAC equipment in order to maximize the performance and reduce the energy costs for our systems. Well, we are aiming to optimize the HVAC controls. And what that means is reducing simultaneous cooling and heating, optimal start-stop for the RTUs and equipment, and temperature pressure resets in order to be dynamically contributing the system overall. Of course, we have demand control ventilation, which basically aims based on the CO2 levels to maintain the occupancy requirements for ventilation and managing the units to meet those energy and ASHRAE codes that we have. By enabling this, we are able to get close to the net zero and reduce carbon goals, as well as we can integrate this to small buildings, to large buildings, and even complex scenarios where we have a cogeneration unit that has to be taken into control with energy distribution and hot water usage. So our systems are able to integrate these together into one point. And overall, we are able to monitor the temperature, humidity, and airflow of the systems. And these sensors can adapt to the changing environment through the occupancy conditions. It gives us real-time feedback. At the bottom left, we can see an RTU, how our graphics will look. And we can see the outside air, the discharge air temperature, how the humidity is being controlled. And we will give you a full-on system that can give you alarms as well if the unit is not running. And on the bottom right, we can see a variable air volume unit. This unit is basically the one that is distributed the air to the space. And we can see the stages for cooling and as well as the reheats. There's two stages. And if there is an issue with the stages for reheats, we can actually change it directly instead of having to replace the whole unit. Well, reducing the simultaneous cooling and heating is definitely going to help us make the system more optimal and prolong the life expectancy of the unit, as we want to make sure that the cooling and heating work together instead of at the same time. We try to do commissioning systems, so we can look at the sequence operation that you currently have, and we can maximize it to meet the new energy codes. We will maximize the unit's performance and make sure that your space is being conditioned towards the temperature and humidity control that you're looking for. The incentives, we work with the utility companies, and at this point, they can give you up to 60% of the project costs and rebates for control systems. And we will walk through the steps with you in order to maximize those rebates on these upgrades. Here we have one of our projects that we're currently working on is in Springfield. It's 1,600,000 square footage facility, 29 floors, They were having simultaneous cooling and heating. So we integrated our control system in order to maximize and manage the performance of this equipment. And with that, and with Eversource, we were able to save 1 million kilowatts per year by introducing our control system. Overall, these savings are towards operational, and also we are going to maximize the equipment wear and tear. Overall, ASHRAE and the Pacific Northwest National Lab are estimating a 30% energy savings if we add a new control system, which can take over all pneumatics, Delta control system, Honeywell's. Our system is able to integrate and have a front end on head, so it's able to maximize the points into one single controller. And I leave it to Matthew, and thank you.
Alberto, Michael, thank you for your presentation. So I know we've given you a lot to digest today. I hope it's been thought-provoking. Final thoughts: electrification. We know the grid can't handle the increased electrical use as it is today. Electricity prices are going to rise. New technologies are going to be available and mainstream to help mitigate those costs. And in HVAC, emerging technologies will be decades becoming mainstream. But keep awareness of other emerging technologies in your near-term projects to ease integration and enjoy the benefits of those systems. As far as controls really are the keys to the kingdom. They can help you mitigate your current system and help you make your current system more efficient, but also help you mitigate energy losses and also give you much better controllability and functionality for your future projects. And with that, I would like to thank anybody and open the floor for questions. There is one question here about pre-development activities needed to reach a project scope definition. That's a great question. So say for a project like a building rehabilitation, the approach to that kind of project would be to find out what the plans are for the building, find out if the customer plans on using any of the equipment there, which if the building use has changed is possibly an opportunity that the system currently is going to be over or undersized based on new use. And I think that you need to scope and share a lot of utility data to build a profile, or if it's a redevelopment, work with the architects on proposed estimated loads. Those two pieces of data will be critical in you reaching a project scope definition. There's another question. How do
Matthew,
you...
I just like to add something to the pre-development activities. Generally, when working with an architect or an engineer, there's a document that's developed, which is called an OPR, Owner's Project Requirements, so that the design team can understand exactly what the outcome success is defined as for the customer. So it's a term you may not know now, but an OPR is something that most architects and engineers will work with you to help understand what those requirements are. And we do basically the same thing as well.
Thank you. Alberto, anything to add to that?
I think we try to maintain communication and make sure that whatever steps we move forward, we keep you together and make sure that we meet and exceed your expectations throughout.
Thank you. The second question, and Michael and Alberto, please feel free to chime in. How do you apply these 21st century solutions to 100-year-old buildings in a practical and efficient manner? That's a great question. I worked on a project in Bristol, Connecticut, which was a derelict 100-year-old school. And the building was converted to 55 very swanky apartments in a mixed income project. And we did cogeneration, solar, and geothermal at the site. And it's critical to get into a project to refurbish a building, from my point of view, as early as possible, to see what challenges you're facing, but also to understand the direction of the project. Michael, Alberto, you want to add anything to that?
Yeah, there is a lot of existing building stock, especially in the Northeast, that is being repurposed. We see those projects come across our desk many, many times. Each one has to be looked at individually to understand what the constraints are. If there are, as the question goes on to ask about structural issues, maybe it's a wood timber floor building and you have to be careful about what you may have to do. Sometimes you just site equipment outside or do a small addition to be able to house all the a new mechanical room equipment. Ventilation becomes one of the more difficult things in these types of renovations, making sure that as you repurpose a structure, you have to bring it up to code, which means paying attention to the ventilation, demand control ventilation, and other DOAS equipment, as we talked about before. So each one's going to be a little bit different, and also you have to look at what the developer's budget is as well. That can, and what the end grade of the final project, what they want to be, Class A office space or Class B. Those types of things all make a difference as far as system selections are concerned.
And I think one important critical aspect that we should add, if you're repurposing a building, the shell is critically important that you meet or exceed local insulation requirements. The tighter the shell, the better the performance of the system and the lower cost to operate the system that way. So I think those are critical things. It's not just the infrastructure that we're going to replace. It's also the shell of the building to get the performance we expect.
For controls, we are also able to take the all pneumatics with the compressor, get rid of it, and we can put the direct digital control systems in order to integrate the Wi-Fi integration, new controllers that can modulate and have the system more dynamically instead of a static system. So we are able to upgrade even 100-year-old buildings from the new controls, and you will be able to see everything from your phone, from your iPad, that the system is overall doing.
So in the interests of time, I know we ran a little over because we had a late start. If anybody is interested in speaking with us about a project or something that's going on in one of your buildings, we'd love to talk to you. It's not going to cost anything to speak. Please feel free to reach out to us. And thank you again for taking the time to join us today and listen to our webinar. Thanks again.
Thank you.